Instead of minimize, I closed it. Looks like fine. So what I was telling is like this Harvard architecture is there, right? So this Harvard architecture basically it will be having two different memory sections, both one for the instructions, one is for the code. So these instructions will be get stored into from the instruction decoder. It will be get stored. What instruction decoder will get, from the program memory, whatever the flashing we have done with the code, right? So if you take if, where is this? If you take if of if one, then you go inside it, you just do the a equal to b. This is the one of the code, right? Okay, this is if loop, okay, in the C language. So this a equal to b will be get converted into the assembly level language. Then after that it will get converted into 0, 1. Then it will get stored into the program memory. So the CPU, what it will do, it has to fetch the data from here to here and then do the processing. The instruction fetch and all for instructions and for the program, it will have the two different memory locations. The physical memory locations, two physical memory location, two physical separate memories will be there. Memory will be there in the Harvard architecture. Okay, but most of the times this Harvard architecture in the high-end controllers, we will not be using it. We needed very consumed memory here, so that's the reason we will be following with the Van Neumann architecture. Most of the high-end controllers, whatever it will be coming, they will be coming with the Van Neumann architecture actually. So in the Van Neumann architecture, what it will be there, it will be having for the entire instructions and for the for the coding, it will have the same memory location. What is it? There will be a same physical memory. Okay, so both the instructions and the program will be there in the will be sitting in the same memory location, physical memory, in the same physical memory, but it will have the, again, blocks. Okay, see here you can see this is one memory space. Okay, here the program is there, variables are there. For variables in the sense like a equal to b we have done, right, in the if language, if loop. So this a and b will be get stored into here. Depends, like, again, this is okay, it might be there in the variables or in the stack. That again we will see it where it will be going to sit in the C language. Okay, so you got it, right? What is this Van Neumann architecture and the Harvard architecture? This is basically to differentiate how the memory, physical memory will be there in the different microcontrollers. Okay, and I hope the other next one is the CISC and RISC architectures. This is basically how the instructions will be handling inside the microcontroller. So I think this you guys have seen in the Girish class, right? So does anyone wanted me to explain it again? I think he explained this topic very deeply.
But I can't see your screen, Lokesh.
Sorry,
I can't see your screen.
is it? Why
Yeah.
here?
Right now, I exit and enter 3 times. Okay, still no, I'm not unable to see your screen.
I'm sharing only. But let me share
Just
again.
a minute, I will let.
Now you can see.
Yeah, now it comes.
Fine. Thank you. So the next level of architecture for the CISC and RISC actually. CISC is a complex instruction set. RISC is a reduced instruction set. So what does that mean? Reduced and complex instruction is what it will be saying about there. So I think Girish was explaining that, like, CISC is like complex instruction set. and RISC is reduced instruction set. So this physically you cannot be able to see how this will be working out and all. I mean in the microcontroller. So, but logically you can try to understand it. If you take like if it is a true, that means you could able to enter into this integer a comma b. This is so in the integer a comma b. In case of complex instruction set, what it will do? This what does that mean? So basically, we're just copying content of b into a. Okay, so to do this again, it will be using some temporary parameter there. So first, what it will do, the b value it will keep into some temporary parameter. Then to a it will assign the temporary parameter. So here there is one more instruction. So the extra instructions will be coming out in the complex instruction set, and it will take a lot of time to execute a lot of time it will take to execute this multiple instruction to perform one of the operation. So that's the reason majority of the microcontrollers will not be following the CISC. So most of them will be followed with the RISC only, reduced instruction set. So all of you know, right? So in the embedded means, so in the embedded, what is the constraint for us? Time is one of the main constraint, right? Timing is the one of the main constraint. To execute this directly, if you are taking two more steps extra, so this almost it is going to confuse. It is going to take 2 times more than what the RISC is going to do. In case of CISC. So, but in case of RISC, what will happen? Directly A equal to B will be happening with some registers. It will be going to use the registers actually. So the B value will be get stored into one of the R1 registers, and for A there will be one more register which is called R2. So the data mapping will be happen between the registers itself. So there will be a lot of time saving, and there will be a good efficiency also. Good efficiency also we can see. So all those things you no need to remember it, but you just know what is the basics of that CISC and RISC and Van Neumann and hardware architectures. So they have given the what and all CISC architecture will be followed is the old microcontroller like Intel 8080, 80286, 386, Pentium and all those things. So the RISC is like will be followed by all these newest microcontrollers like Infineon controllers or the NVIDIA controllers or Texas Instruments latest controllers and all those things. Whichever is having 16-bit or 32 bits microcontroller, they will be using the RISC architecture. Guys, this is very basic, but don't worry about these things. So if you are not able to understand also, moving forward by seeing all the coding things and the microcontroller things, you could able to get it. What is that mean? I'm sure at the very first time you could not able to understand this entire embedded systems, but definitely moving forward you could able to understand with the real-time examples. Got it?
Yes, yeah. Good.
So next we'll see what is that 8051 microcontroller. So if anybody wanted to start with any of the microcontroller, if you want to start with the microcontroller, okay. 8051 is the very basic microcontroller. If you understand this 8051 not thoroughly, but the basic things, then you could able to relate this concept with any of the microcontroller. The microcontroller will be coming with the better features, that's all, but the almost the architecture and the features whatever it will be having, all of them will be have. It might be having one timer, it might be having one ADC channel, it might be supportive for only one or two communication channels, but these parameters only will be get changed in case of, you know, if you take the Infineon, whatever yesterday night we have seen it, right? Infineon TC3X something. So it will have the nearly 5 or 6 timers. It will have nearly 8 or 10 ADCs. It will have nearly 10 CAN channels it will support. It will support 10 Ethernet channels. So something like that. The number of features it will be more, that's all. But the whatever the peripherals it will be having, the same peripherals will be there in the almost in all controllers. Getting it?
Yeah, Lokesh.
There was a microcontroller. Yeah. So let me take this diagram. So can anyone guess what is this diagram is about? Any guess? Even if it is wrong, it is fine for me.
It is a schematic diagram of 8051.
Any other answers? Architecture. Any other answers?
PCB.
Microcontroller combination of CPU, bus registers, everything. Arduino, IPO ports.
Okay, perfect. Any other answers? Fine, most of you guys are correct. Okay. What it is saying, you know?
Water level controller.
Sorry, can anyone tell once again? Someone saw it.
Water level controller using 8951.
Correct. This is basically 8051 family only. In that 8051 at 89S51 something it is, okay. This 8051 they will be coming with a different family. So this is one among them, okay. So this is the controller which it is trying to give the what is the water level in the, you know, tank. So this is how physically, you know, microcontroller will be there, then how the power supply and how the motors will be get connected it. Getting it? So this is the LCD module. This is a controller. This is a power supply. So if you see in any one of the project, this kind of schematic diagrams is this is basically ultrasonic water level controller schematic. So this is the, you know, motor, I think so. So what it is giving, you know, so there is some sensors. This is ultrasonic sensor or what? This is not power supply. Sorry, yeah. Power supply is here. Power supply is here. This plus and minus. So this is ultrasonic sensor. Even ultrasonic sensor also needed some power supply. So depends on that, it will give some trigger and echo signals to this microcontroller. Depends on this ultrasonic sensor, the controller can get it. What is the water level? Okay. So if water level is below the threshold, what we are meant to do, keep it, then it will automatically trigger for the motor supply. This motor will be filling the tank. Got it? So here it will be having some crystals. We are talking about all the microcontrollers, timers and all, right? So it will have internally timers. These timers will be controlled by the crystal. Don't worry about how this crystal and all it will work. No one knows it apart from the electrical guys. there is a logic behind it. That is a phase lock loop logic actually. So that phase lock loop logic will be having some capacitors and all those things, but don't worry about all those things. Okay, each and every microcontroller minimum it will have one crystal. So this crystal will be doing the all real-time timing operations. Got it? The timing operations in the sense this. What is this ultrasonic sensor, right? This ultrasonic sensor might be sensing at every 10 milliseconds, or this is anyhow water level, right? It might be sensing at 1 second. So to sense this at 1 second, this 1 second time period will be provided by the crystal. Okay, and it might be, you know, it has to give the output on the LCD for every 10 milliseconds or 50 milliseconds. So this 50 milliseconds also will be provided by the crystal only. So crystal is basically to generate the clock timings. Each microcontroller it will have it. Getting it? Don't worry about what is this resistors and all those things. This resistors is for controlling the LCD. This LCD, you know, right? Everyone saw the LCD, right? What can I give? Where you can see it here. So if you go to, can anyone tell me the example where you can see the LCDs?
And
Our,
railway
elec
station.
our electrical
Calculator.
meter is there na? There,
Electrical
so
meter
our
and
calculator.
calculator, digital watch, and all these things are the LCD modules only. Okay, so that LCD module depends on the resistor values what you are giving. That brightness might be changed. Okay, in our watches we might have seen the brightness change, that knob, right? That knob basically it will be connected to the one of the resistor. So if you are changing that resistor value, then the brightness might go increase, or it might come down actually. This is also needed power supply. See, basically what you need to remember, you know, each and every electrical or electronic needed some power supply. So here this is electrical device, sorry, electronic device. This is electronic device. Motor is the electrical device. The ultrasonic sensor is the electronic device. All these guys needed power supply. Okay, that's the reason you can see 5 volts here, 5 volts here. This guy is getting 12 volts. Getting it? All these guys needed the power supply, but main power supply we will be providing from the outside. This power supply will be splitted across the, you know, different microcontroller, different electrical devices wherever it is needed. Guys, got it? So this is how the 8051 microcontroller will be using it. In the upcoming slides, what you could able to see is like this P2.7, P2.6, P2.5, all these things you could able to see. These things. These are the DIO pins, digital input and output pins. So here P20 is there, P3031 is there. Okay, these are the digital IO pins. IO in the sense input and output pins. But no one requires what is this pins and all those things. If you are a software developer or the tester, we will not be looking at the microcontroller at all. We will be, you know, bothered about whether whatever the software we have flashed it into the microcontroller, whether it is get flashed, whether it is working fine or not. This entire setup, this entire this entire thing will be done by these connections and all will be done by the electrical engineer. If anyone is there from the EEE background, they could able to understand it. They will be doing this, all these things, connections, everything. But for your basic understanding, I'm just bringing you these topics into the into the class. Got it right? Guys, any doubt in that previous diagram? If no, then we can see what is that circuit is about. What is explaining. See, what he is explaining is pin 31 and 40 connected to the 5 volts power supply. Okay. See here you can see 31 and 40 connected to the 5 volts power supply. Pin 20 is connected to ground. So why ground is needed? Can anyone guess?
Earth.
Correct. So it's kind of like if any of the power supply is there, then definitely it should have the neutral, ground supply as well. Okay, this is kind of earth. So all these things the electrical guy will be taking care. So this you can see pin 18 and 19 are connected to crystal clock. Where is that? 18 and 19 here you can see. So that what and all pins are there, how they are connected with each and everyone is what he is telling. The microcontroller needs the basic connection to start the executing program. Program needs to be loaded into the flash memory of the microcontroller. So what he is telling? So this we have seen yesterday, right? So each and every microcontroller will have the memory organization. Inside it, it will be having some flash memory. So inside that, whatever the program you will be flashing, it will be loaded it. So that memory will be having the memory addresses, okay? So that memory address, it will depends of the number of bits of microcontroller. So if it is a 8-bit microcontroller, this will have 8-bit memory address. 8-bit in the sense only 2 will come. This is 4 bits, this is 4 bits. If it is 16-bit, then it will get the 8, 16. Each bit will represent 4 bits here. One nibble. Okay, something like that. Okay, that's the reason he is giving the very big. This is a 16-bit controller, so that's the reason he has just kept it 0000. So each microcontroller, the starting address will be the 0000. So once you are giving the power supply to the microcontroller, it will go to that particular 0 address. From there, it knows what it has to do. Okay, what has to be done? How will it get to know? There will be one code. Okay, that code will have the one instruction. That instruction will be get executed. Then the subsequent functions will be get called. Function calls will happen. Okay, getting it?
Yes, bro.
Or you guys are getting confusion, or still it is okay to proceed?
Go ahead, bro.
Fine, thank you. So, and what that is what he is explaining, like it is going to go to the 00 address. Then the microcontroller knows that what kind of instruction it has to be executed. Once if it is executes the first instruction, then it knows what kind of what will be the next instruction it has to be executed. So this is a sequential execution. So if you take our previous example, so you have done the whatever we have done, what is that washing machine, the same way you can analyze this one also. Got it? So this is the assembly level language. Whoever they're from the EC or CSC background, they could able to understand it, but it's nowhere used it. Okay. So, but I can just give you the overview about one particular assembly language code. Then you can get to know it. So what he is telling, turning on relay connected to the port 00 on and off with a short delay. Where is the diagram? Where is this port 00? This is the one. Port 00 is there, right? For this, he is trying to do the some coding, okay, to control that port 0. Port 00 in the sense, there are 3 ports actually. Out of that, P0 is the one port, P1 is the one port. Where is P1? P1 is there somewhere, P2 and P3. Total 4 ports are there. Out of that ports, again, it will have 8 pins. P0.0 means port 0, in port 0, 0th pin. P0.1 means port 0, first pin. P0.2 means port 0, second pin, like that. So it will have, yesterday we were discussing, right? It will be having, sorry. Yesterday we were discussing, right? The controller might be having nearly, from 30 to 140 pins also it is possible. So 1, 2, 3, 4 until 140 we cannot give, right? So that's the reason they will be segregating. If it is having 150 pins, okay, then they can segregate each 5 ports, P0, P1, P2, P3, P4, something 5 ports. This port might be having 15 pins. This is 15 pins. This is 15 pins. Or like 5 means this must be having 30. I'm just taking as an example, okay, 30 pins. So if there are 5 ports, each port is having 50 pins, means total 150 pins, so that microcontroller will have it. Got it? So that is the thing what he has mentioned here. So port 0.0 is trying to control the relay. So port 0.0, if you are giving the 0, then it is the off state. If you are giving the 1, then it is a turn on. So that's what he is telling. So move P000H. Can anyone tell me what is this 00H? In which format it is there? Number systems, right?
Hexa format.
Hexagon.
Yeah, this is in the hexa format. So there is a 2 ways of representing it. One might be, let me take the screenshot here. I cannot write in the PPT or in the PDF. That is the problem. Let me keep here. So yesterday we were discussing it, right? So this hexa format, it might be there with the 0x00 or 00H. The either way you can able to represent it. So what does that mean here? Move P0 to. So first will be the instruction type. Guys, don't worry about these instructions. So what is this assembly level language and all those things? So this no one will be working. No one will be writing this in very rare cases. In very rare industries, they will be following the ASM coding. Okay, but if anyone knows in this ASM coding, they will be for them there will be a lot of demand. Okay, so can anyone guess what is this move P0, 00H? What it will happen in the exact, any CSE guy or ECE guy or anyone who is having experience in the basic experience in the embedded systems? Guys, can try it. No need to be a perfect answer, as all of you know already.
I think pointer has to go to that particular value.
Then, yeah.
While executing that, pointer has to point at what we call it as program. First level, move to that pointer, move to 0. Then there it will be start the execution. Then go to 01H. I think so. No.
No. Any other guesses? Fine, bro. What will happen here? Can you tell me what is this assembly level language program with respect to the previous diagram we are explaining? Okay. You saw what is this P00, correct? So P0 is a port number, okay? So 00H is a value. You are not talking about any memory here, correct?
Okay.
So 0 0 is you are not doing any transitions with the memory, but definitely memory transitions will happen in the back end, but the front end, what it will happen here is what we need to understand. Got it? So what does this mean? Can anyone tell me what is that move? Before that, let me give you one syntax, okay, how these instructions will be there. This is first, it will be the instruction type, then will be the destination, and then the following with the source, okay. Now source is the 00H, destination is the P0, and instruction type is the move, which means that whatever there will be in the source, make that value to the port 0 means move. This 00H will be there in the some memory, and P0, this related port configurations, it will have this this P0 will be reading this data from particular memory. So you are doing basically the memory what can I say, memory copying from source to destination.
So
From
addressing the
source,
pointer, right?
correct. But in the front end, how it will looks like is like 001 00H. You are making, so port P0 you are making it as a 00H. But in the back end, this 00H will be there in the one memory. This P0 will be there in the other memory. That memory mapping will be happening at the microcontroller level.
Now I got it.
Yeah. Everyone got it, right? So this is how assembly level language. So let me take now the example what we were seeing it. If loop is there, if one, A equal to B, we were doing it, right? So B is the variable which will be there in the so and so address, okay? Before moving that address, let me keep that into the assembly level. It will happen, copy is the one instruction, CPY, copy or something will be there. I don't remember all these instructions, okay? Guys, don't worry about this instruction names and all. Microcontroller to microcontroller, there will be changes, but this move, SJMP, dgen, return, and copy, there will be some standard instruction type that will be common for all the microcontrollers, but some will be having some different kinds of instruction sets also. Fine. So this will happen, copy, what you are doing, who is the source here, can anyone tell me?
00H is the source.
00H.
No, this example you are telling, but I am asking about this example. A equal to B is the code in C language you have written it.
B
A
is
is the source.
Can you repeat once again? Which one is the
A
source?
is the source.
Uh-huh.
We are accessing the A value into the B.
Hey, sure. Can
B is the
anyone?
source.
Okay.
If B has a value, so
Correct.
if A equals to B, then some program will be executed.
Exactly. So here B is the source, A is the destination. Okay. So what will happen in this program assembly level language? You are doing just copy, right? Or you can do also move also. What you are doing? From B to A you are doing it. Got it? But exactly the memory, this parameter names will not be coming here. So it will be coming with the register names, okay, R1, R2 and all. In the microcontroller we saw it, right? So it will be having some small registers. So yesterday someone told this can able to store 1 bit of information. R1, R2, something like that it will be have. So this entire memory mapping will be happening inside the microcontroller. So here assembly level language will be handling with the R1 or R2. So let's take example. So B, the value of B is a parameter name, okay? The B value will be stored in the R2 register. So the A value is occupied by the R1 registers. Now what you are doing, from R2 to R1 you are doing the moving, means copying. So this is what the assembly level language. So first we have seen the coding in the C language. Then we got to know how it is getting converted into the assembly level language, but we will not be converting this and all. Okay, there will be standard compilers to do all these things. We will be just writing the C language coding. Got it right?
Yeah, bro.
Yeah. So in the particular example, whatever we have taken it, so you are just making P0 port 0 to the off. Okay, then you are giving some delay, which means like 1 second to 5 seconds. That delay you are performing. Then again what you are doing, move P0 to 01H, means you are turning on the relay 1 connected to P00. Then again a delay, which is a 5 seconds. Then you start or stop, it will be, I think. So this is the start, delay, wait, end. These are the keywords in assembly level language. We will be using it, but don't worry about this coding. Okay, only EC guys could able to understand it properly, but that's fine. No one knows what is the perfect assembly level language. So this is how they will be performing some kind of operations on 8051 microcontroller. So there is a microcontroller. It is meant for the water level controlling, water level indicator, I can say. So that this water level indicator is having some kinds of peripherals on the DIO pins. That DIO pins, how it will be acting is depends on the assembly level language. That assembly level language, at the end of the day, it will be get converted into the binary levels, zeros and ones. But inside the microprocessor, we are having the CPU, right? That could able to decode it. So we saw it. Where was that? See here, you can see there will be some instruction decoders inside the CPU. Okay, that instruction decoder, if you are giving 10001, then it knows that what it has to do. Even I doesn't know how it will do that decoding. Okay, but guys, don't worry about all of those things. I want to see. My primary intention is like, you guys should not be get surprised after entering into the company by hearing all these words. That's the reason sometimes I might be going beyond the limits also to explain you guys what is needed it.
Yeah, right.
Got
Yeah, got it.
got it right?
Yeah.
Yeah, perfect. Then and most of the times what is exactly needed only I will be explaining. Okay, here he has just given how the pins you can operate and all those things. I don't want to bring all those things, but it's fine. If you want, anyhow, I will be sharing these PPT. You can go through them. Next, I wanted to see the peripherals. Okay. Next class onwards, I will try to open this PPT in the notepad only, notes only here. I cannot take every time snippet. Yeah. Can anyone guess what kind of peripherals we will be there? Can anyone tell me what is the peripherals in the microcontroller? We already discussed a couple of times. Any guess? Guys, can tell me. If it is wrong also, it's fine. Can anyone tell me what is the peripherals?
External devices.
External?
External device what we connect.
Correct.
Like mouse,
Mouse is the
earphones.
peripheral for the computer.
Yeah.
Correct.
Display, screen.
Timer, memory.
Correct. Hey, wait. Memory will not be coming. External memory, if you are connecting, that also one kind of peripheral, but there will be internal memory that you need to aware of it. Earphones in case of headset, yeah, perfect. In case of a computer, what kind of other peripherals it will be there? Tell me.
Keyboards,
Keyboard, keyboard,
display,
printer, correct.
display, scanners,
Display, scanner.
and
These all are
mouse,
the
webcam,
webcam.
that is
Yes.
also one peripheral. And
These all are the peripherals to what?
To the computer.
To the computer. So same way for
Yeah.
our microcontroller also we have the peripherals.
Input output ports, timers.
Correct. GPIO. Can anyone tell me what kind of peripherals it will come here? GPIOs, timers. Then
Ports, IO ports.
this is what GPIO, right? GPIO is IO ports only.
Yeah.
So this ADC, DAC, serial number, PWM, and all those things it will come. Okay.
Analog
So,
to digital,
Analog to digital conversion.
yes, analog to digital, digital to analog converters also it will be coming under the. So if you take here ADC, DAC, and what else we have seen there? Yeah, in that PPT.
serial.
Communication ports, communication port, serial communication basically. Serial communication ports and all, they will come under the peripherals of microcontrollers. Okay, so we saw it already. What is the use of GPIO? To connect to the external devices, like it might be sensors. In case of our washing machine, sensors will be get connected as a input to the microcontroller, right? And in case of my washing machine itself, so this motor will be there, na? Motor will be get connected as a output from the microcontroller. Correct?
Right.
So the same way the GPIO pins will be used, and also we have seen right now for connecting the power supply, and for connecting the crystal oscilloscope. With this crystal oscilloscope, there is some significance. I don't want to tell that now. What is the need of it and all?
When it gives to power supply, it will turn on the timer.
Correct. Exactly. This main power supply will be input for all the peripherals whichever it is needed. Even
bro, one doubt, bro. GP means what it, bro?
General purpose.
IO means general purpose. Okay, right.
General purpose.
IO means input output.
General purpose IO. Input and output.
Yes.
Got it, right? And timers
Right,
also
right.
needed the timings. So you can see here pins used to turn on, turn off, read logic, high logic, low levels, used controlling relays, transistors, display devices. All these are for the input output ports. We saw it in the previous diagram, right? So what it was connecting? It was connecting to the LCD. It was connecting to power supply. It was connected to the motor to turn on, turn off. It is connected to the ultrasonic sensor to get the inputs. All those things will be handled by the IO pins.
Right.
The next is the timer and the counter. So timers and counters, as we discussed already, these ultrasonic sensors might be need to sense for every 10 milliseconds. Okay, this 10 milliseconds it will be get created. This is a part of coding. Okay, hardware timers will be there. But how we will be using the timers will be part of the software development. Got it? This definitely we will be seeing. If anyone, if I forgot also, please guys to highlight in that particular class whenever we will be seeing the software in the real time. Okay. So what he is telling, peripheral used to count events. So what will happen if there is a failure in the motor, okay, in our previous water level indicator itself. So if there is a failure in the motor, so it will be keep on seeing it. Okay, there might be a power glitches to the motor. That's the reason motor could not able to turn on. So it has to wait for the 10 times. Microcontroller will try to run the motor 10 times. If it is getting negative signal from the motor, then again it will try after 5 seconds, something like that. This is electrical device, right? So it will have not 5 seconds, it will have some delay. Okay, so to make these counts and all, we will be having the counters in the microcontrollers. So that counter will be getting stored. Even you can make it as a variable. Yeah, that doesn't make sense for me. In the coding there will be variables. Okay, that if you that for every 10 milliseconds there will be one function will be getting run. So inside it you can have the one counter parameter. You just increment it. That also you can do, but these counters I never used it, but that this is for that one only. And the timing between the two different events. So now the microcontroller is tried to turn on the motor. Then again, there is a failure. It could not able to turn on the motor. Then there should be a difference between the next event, right? That difference also these counters could able to handle it. And the timers will be used to schedule the events. So basically, we are talking more and more about timers. Right? Let me give you the little bit brief overview about the timers. So guys, if you take the on real time, let's take the particular example only. So in the coding, if everyone knows about the basics of very coding, in C language there will be a main function. Okay. Again, this topic in the coding we will be touching it, but still, let me tell about the timer here. So that coding will have the main function. Inside it there will be some timing. There will be a functions, right? That might be static functions. Guys, if anyone is from CS background, please open up your mouse. This is your topics. So these functions, if there is a power supply actually, then this main function will be get called. This main, it will have some functions inside it. These functions might be running at the periodic level. Periodic means, can anyone tell me what does that mean? Periodic code?
Like
Periodic. Correct. This will be running at the interval level. To some specific, either it can be running at 10 milliseconds or 50 milliseconds or 100 milliseconds. Guys, I will be talking about in the milliseconds, nanoseconds only. In very rare cases, we will be seeing the seconds. Why? Because most of the functionality has to be happening with the milliseconds in the embedded systems. If you take the airbag systems, can anyone guess within how much fraction of seconds airbag should be open if there is an accident?
1 millisecond.
Any other guess? 1 millisecond means how much, It will be 1 by 10, 1 lakh. 1 lakh parts of 1 second. That much fast the airbag should be opened. So you can imagine like how fastly the microcontroller should work. So within 1 millisecond, it should be able to analyze the whether the whatever the accident is happened, accident is real or not. So to classify itself, it will take a lot of time if you think in your mind itself, but the system knows whether that is accident or not. So within the fraction of microseconds, it could able to open the airbag. So that's the reason we will be keep on thinking about the seconds, milliseconds only here. 10 milliseconds, 50 milliseconds, 100 milliseconds, 1 millisecond, 1 nanosecond, 1 nanosecond, 1 microsecond. So this something like this it will be going on. Don't worry about this. So but most of the embedded systems will be handled with a very little time fractions. Okay. So this timers and all, this 10 milliseconds or 1 milliseconds in case of airbag system will be handled by the timer. See here, timers to provide the periodic time intervals for the program scheduling. So you will be keep on see this airbag functionality will be keep on checking for every 1 microsecond. Sorry, milli means 1 by 1000 here. So this airbag functionality will be checking for each and every 1 microsecond. If there is an accident, then definitely it has to perform. So if there is an accident, all other functionality will be get stopped. Only airbag system functionality will come into the picture. Okay, so this is the reason for using the timers and counters. Okay, where are we now? We are at the timers. Just give me 2 minutes. We will finish the two or three more are there. Can anyone tell me what is the ADC? So these are this ADC, DS and serial also. ADC, DSA and serial communication also peripherals to the microcontroller. Can anyone guess what is that? Yeah, where is this pen? Can anyone guess what is this ADC?
Here on the analog digital converter.
Analog to digital conversion.
Analog to digital converter. Can anyone tell me what does that mean?
Is graphical system to numbering system.
Sorry. Can you please repeat once again?
Graphical system to numbering system. I mean LCD, LED.
Graphical system to number systems. Can anyone guess? Any answers? What do you mean by analog?
I think from binary to decimal.
No, that anyhow. No, it's not correct.
Okay.
Any other guess? I will tell you anyhow. Can anyone guess what is that analog?
Analog means
Like when we use a remote
old watches or
remote
old
control to TV.
speedometer.
Remote control to?
When we like use the remote controller to change any channel.
I think analog is understood by the humans. Digital is understanding by the computers or microcontrollers, I think.
Any other guesses? No guesses, huh? See, basically, what does that unlock? This is a continuous.
Like one more thing, Caleb. From
Yeah.
like symbols to decimal means like numbers.
What do you mean by the symbols?
Like some diagram.
No, that's not correct. So, unlock means continuous. Okay. So, can anyone tell me what will be the continuous values in the microcontroller? So, that is the voltage levels. Okay. The power supply. Got it? See, the sensors and motors, how they will be working with the voltage only, right? Basically, voltage and current only. So we will be providing some voltage levels. If these guys are started working, then they will drag some current values. So these are the continuous values. Okay, this voltage is the continuous value. This voltage might be, it will be 1.1 volt, 10 volts, 12 volts, 24 volts, 32 volts, something like that. It will be there. Got it? So these analog values, this 10 volts, 5 volts, 24 volts, 32 volts will not be understood by the microcontroller. Correct? We are studying from last 3 days the same thing, right? Microcontroller will be able to understand either 0 or 1. That's all. It cannot know what is this 1.1, 10, 12, 24, 32 and all those things. So this analog, the voltage levels will be get converted into the digital values digital values which is 0 and 1. Getting it? For this purpose, we will be using the ADC, analog to digital converter. If you are giving analog value 10 volts, then it will convert that to 1010. Not 1010, again there will be some formula behind this. I will tell you that. Got it? Guys, getting or it's making you to
Getting.
confuse?
Yes.
So you
Yeah,
take, okay, this ADCs will be having some values, okay. ADCs, basically it will be 8-bit ADCs, 10-bit ADCs, 12-bit ADCs, something like that it will be having it. So 8-bit in the sense, it could able to convert 2 power 8. 2 power 8 means how much, can anyone tell me? $256. Can anyone tell me what is the value of 2 power 10? 1024. Can anyone tell me what is the value of 2 power 12?
4096.
Perfect, 4096. So if ADC is a 8-bit means whatever the analog values it will be getting it, that analog values it can divide into the 256 parts. Getting it? You can see here, for example, 8-bit analog to digital converter will convert a 2.5 volt signal to this value 128 and 5 volt signal input to 255. So it can able to split the 256 values, but it will have from 0 to 255. Why? Because 0 also is a valid number. Including 0, it can support 256. Okay. So what it will be having some formula here that even I forgot it. Just a minute. Hey guys, I'm back. Sorry. Where is this? So this analog values, it can convert the 256 into whatever the analog value it will be getting, that it could able to convert into the 256. 256 parts. This 2.5 volts is there, right? That it can convert into, see, for example, if it is a maximum, it is going to get the 5 volts. Okay, that 5 volts it could able to split into the 256 parts. Okay. So out of that is what he's telling. Okay, if it is a 5 volts means 5 volts means this is the maximum value you can get it, right? 255. So that 255, how we can represent in the, this is a 255 maximum value in the 8-bit representation, right? 8-bit ADC. 8-bit ADC in the sense it can hold only 8 bits of value. So if it is a 5 volts you are getting from any sensor, okay, sensor is giving the 5 volt supply. Then how the ADC will convert and ADC will give that value in the 11111111. Can anyone tell me what is this value of 11111111?
15.
1515.
Yep.
The hex it will be FF, right? In the decimal, what value it will get?
13.
Oh yeah, 13 how?
8 plus 4 plus 2 plus 1.
8 plus 4 plus 2 plus
12.
1.
Sorry. Yeah. 12 plus 2, 14, 15. 15.
15 means in hex format, how much that is? 15
FF.
means what? FF. If you are giving hex value FF, what is the decimal value? 255.
255.
250.
Correct, right? So if you are giving 5 volts, which is a maximum value, then the value will be get converted into the FF, which is a 255. Okay. Let me find out what was that unlock to. So there is some converter formula, okay, but I could not able to remember it. But see, you could able to understand easily it. But this is how the ADC is used, okay. From ADC is like from analog to digital converter. If you want to do any conversion, then the ADC will be there.
I think there will be AND and OR operations with there.
No, yeah, and R operations. It is the direct formula. Like
Okay.
what is the like if you take 5 volts you are getting, right?
Can you please
2.5 volts
elaborate
you
it?
are giving. Sorry.
Can you please explain it? What is the formula behind it? I want to know it.
That's what I was trying to find it out. Even I forgot it. So it will be how, like, 2 power number of bits minus 1 is the maximum number of partitions that you can do. Number is the, in this case, 8-bit ADC means 8 it will be. 2 power 8 it means what? 256 minus 1.
256 minus 1.
255
255.
partitions it gave you. 8-bit ADC means. This 255, how can you convert into the digital is like, there will be different techniques, okay. The one technique which I remember is like, what was that, yeah? I forgot. There will be some reference voltage. With that reference voltage, it will be keep on doing the error feedback mechanism actually. A successive approximation. If anyone is interested, okay, you can go through this method of ADC calculation. You will get to know how the ADC conversion will happen. Okay, but as of now, it's not needed for you. Bro, Vidyadhar bro, if I found that ADC conversion formula, right, there is a direct formula. Instead of having these methods and all, there is a direct formula, but I could not able to find it out.
Okay, I will Google it, and once
yeah.
I will let you know, I will ping you.
Sure, yeah.
Yeah.
You can try it.
Yeah.
Okay, this is how the ADC will work out. Okay, DIC is something digital to
Same
analog
like
converter, but
same
ulta.
like that. Ulta, right.
Correct. So from microcontroller, if you want to provide any data to the motor cannot able to understand zeros and ones, right? It needed some power supply. So DIC will be used for that. And serial is the communication ports. Okay. So if there are two devices, okay. Does anyone work on the what is that? Yeah. Arduino.
In college, I make project and Arduino.
So this Arduino, if you are having two Arduinos, okay, to make them connect with each other, we will be having some kinds of communication method. So each microcontroller will have some kinds of communication peripherals. So that communication peripherals is SPI, I2C, CAN, LIN, Ethernet, FlexRange.
Mesh and node.
Mesh node. What is this, bro?
Mesh and node,
Mesh-
bro.
Mesh and node is a different concept. Okay.
Okay.
That is like how the looping will be happening. Like if too many devices are getting connected, what kind of loop that is? Whether that is a round robin, something is the mesh node and the network topology. Basically they all are the network topologies. Mesh node, all those things. But these are the different. Okay. SPI, I2C, CAN, LIN, Ethernet, FlexRay. Ethernet, everyone might be knowing it. The actual Ethernet, what we will be using it. CAN is the which it is very important. We have the separate, very big topic for that. Anyhow, we will be seeing it there. Okay. Got it. And can I take 5 or 10 more minutes more? That's fine for all of you. I just wanted to finish today. The memory organization will be going to the C language that anyhow I will not be seeing it here. And embedded systems in automotive I wanted to cover. Before that, autos I wanted to see. This high level I will give you, but again, if anyone interested, you can come back to me, or also I can give you the pointers where you can get more information about this. Fine for everyone if I continue for 10 more minutes.
Please go through.
Can anyone tell me what is operating systems? Everyone will be hearing it. Operating system,
Okay.
OS.
It's software like software. Computer software.
Yeah. Any other guess?
Number of programming executed by sequentially.
That is coding. What is the difference between OS and the actual application code?
It manages the hardware and software resources. Operating system.
Similarly, yeah. Any other guesses?
Like computer software which operates system performance.
Yeah, that is the Windows OS what you will be seeing in your laptops, right? It might be Windows. It might be you might have heard the Windows OS.
Linux will be there.
Linux will be there.
Mac is there.
Mac OS will be there.
Android.
These all are laptop OS, okay.
Android.
In case of mobile phones, in laptops also Android is coming. Then this what is this mobile here? Honor and all
Yes.
they're using something else here. Honor, OnePlus, these guys like something
Oxygen.
else.
Oxygen OS.
Oxygen also it came recently.
Their version of Android.
Hmm?
Their version of Android. Like
Correct.
their own version of Android.
They will be having their own OSs and all, no? So each manufacturer is coming with that idea. Why, this is out of our topic, but still. Can anyone guess what is the reason? The similar kind of scenario is there in the automotive also. That's the reason I wanted that answer. Can anyone guess what is the reason every manufacturer is coming with their own OSs?
Unique and security.
That one reason.
But scope for development.
User
They can
readability actually.
Main reason what cost
Security.
effective. Cost
Okay.
effective.
Okay.
They don't want to spend a lot of money for this Android, Google Android or someone else. They wanted their own product. The similar way, all the automotive companies also they are coming up with. Previously, they were if you take the BMW itself, Previously, what they were doing? They were buying engine from the Bosch. They were buying brakes from the German OEMs,
Yes,
German
yes.
tier one, and they were buying
And
entire
power.
body from the someone else. And then they were merging it. But the technology will be these guys only. They will merge it. They will sell that car for the 70 lakhs. Now these guys are coming with the plans like the software also they will develop. They will implement their own, but they will take minimal support from the other companies, which will do the cost reduction. Got it? Same thing like your company also, bro. Vidyadhar, bro. Your company was doing this, this ADAS technology.
Yes.
ADAS technology. Previously, they were buying it from the mobile. Means
Okay.
like finding the images and doing the image processing on that and all.
Mm.
Now what these guys are doing, from mobile they are not buying now. Now these guys only developing the software, which will reduce a lot of cost for these guys. Previously, mobile was the supplier to the Aptiv. They were supplying the software to Aptiv. Now they are taking the projects from from Aptiv to the mobile. So which became Aptiv became supplier to the mobile. So now see how the business changed now. Previously, mobile, Aptiv was giving money. Now, mobile is
Active
giving money to the
okay,
money to Aptiv.
to develop the software.
So that's how they are doing the in-house software development. The same way for the mobiles and the OS. So this Windows, Linux, Mac OS, and all those guys. Also. MI also will come up with their own OS if they wanted. That's how the industry is there now. So can anyone tell me? So in every laptop, it will be having the OS, right?
Yes.
So what does that it will do? It will just open the some kind of user interface it will give, correct? But in case of microcontrollers or the embedded systems, we will not be seeing any operations on the screen, right? Until unless if you are connecting any HMI or the LCDs. So whatever the software execution will be happening, it will be happening within inside the microcontroller only. But all the things is the time critical. There should not be any delays. Every task, whatever we were discussing, like airbag system, it should happen within 1 microsecond or 1 millisecond time. So to achieve this timing period, so we have come up with the real-time operating system, which we call it as a RTOS. There are different operating systems, QNX, and there is something else. Recently I heard it, I forgot it. But these two things which I remember frequently. RTOS and QNX, they are competitors for each one of them. Okay. This RTOS is just operating system for the microcontroller. In microcontroller, apart from the code, what you are trying to, what you will be flashing, it will also have some operating system. If you are flashing the code, there will be someone to accept it, right? This will be handled by the operating systems. Okay, got it, right? Fine. Now, let me bring the last topic to today's concept. Can anyone guess what is the role of embedded systems in the automotive? Can anyone guess it?
Perfection.
Why embedded systems are entering into the automotive? As we discussed in our first class, itself we saw it, right? How the world cars were there. Only mechanical parts were there. Now, but we are getting everything with the electrical and the electronics. If you take any of the vehicle now, without electrical and electronics, nothing will be there. Any of the vehicle you can take. Can tell me what is the need of embedded systems in the automotive? Automotive in the sense it might be, automotive means, can tell me what kind of things it will come under the automotive?
Parking sensors, cameras.
No. I don't want to go into that much deep. I just wanted what does that mean automotive term?
Steering.
No. Automotive means vehicles. Automobiles I can say. Automobiles. This is part of automotive industry. So we are into the automotive industry. Got it? Whatever we are doing, at least myself I am doing into the automotive industry. We have developed different kinds of ECUs. I have worked on the ADAS ECU, which is a driver assistance ECU. I have worked on the airbag systems. I have worked on the gateway ECUs. I know how the entire braking ECUs will be working. I know how the steer by wire and all those things will be working. So these all things will be coming under the automotive industry. So whatever the topics we will be seeing moving forward will be part of the automotive industry. Okay, vehicles means it might be passenger vehicles. Passenger vehicles in the sense it might be cars, buses, it might be heavy duty vehicles also. Sorry, heavy duty vehicles. Which heavy duty means
Off-road vehicles.
off-road vehicles, and these lorries and all trucks and all it will come. Got it? What does this mean? Automobile and automotive. Okay. If you guys are fine with these terms, then I think it's going beyond. I think it may take nearly 10 to 15 minutes. This will take tomorrow. With this, I just wanted to finish. Now, what is the need of embedded systems? You guys can think about it and come back to the tomorrow's class. We will discuss about this topic again.
Yeah.
Think and see, and also just see what is ACC, what is AEB, what is LKA, what is LDW. All these things. Don't worry about the spellings here. This I have just copy pasted. It might be entered wrong when I was typing it. So
Bro, in my project there is LKA and LKP there. I wanted to know that what that means. I think so.
LKA, LKS will be there. LDW also, I'm sure it will be there.
LKPE,
LKPE,
LKPE, ABS and VAS. Yes,
ABS, and what is else?
I'm very much in VAS.
VAS. What does that mean? VAS?
VAS. I think it is a charger connected motor. I think
Okay,
it will
fine.
be there.
Yeah, fine. So guys, everyone just think about what is the need of embedded systems in the automotive and come up with your own answers tomorrow. Either if you are Googling also, it's fine for me, but you should able to understand what is the need of embedded systems in the automotive and how the different ACC, AEB, LKA, LDW features are working in the vehicles. You can just search in the Google what is the ACC feature, what is the AEB feature in the vehicle. Definitely, you will get a lot of videos about them from the different OEMs. OEM in the sense either from Ford or GM or from Kia or like BMW All these guys are the OEMs. So those cars are already having these features. Just look at the videos and come back to tomorrow class. Does anyone have any questions? Sorry for late. Anyone have any other questions? If not, then I will be stopping today's class.
No.
Thank you all. Bye bye. Good night.
Thank you.
Thank you.
Thank you.